The spread of digital technologies in farms has led to an increasing use of vegetation indices, such as NDVI. Vegetation indices are calculated from data collected using drones or satellites. Commonly used satellites have regular acquisition intervals, such as 5 days or 16 days, so indices are available for multiple dates in the same season. The sun emits radiation with different wavelengths and frequencies. Vegetation absorbs solar radiation in different bands, that is in different frequency ranges and wavelengths, and emits a different percentage of it back into them. The most used vegetation index is undoubtedly the Normalized Difference Vegetation Index, NDVI. It describes the vigor level of the crop and it is calculated as the ratio between the difference and the sum of the refracted radiations in the near-infrared and in the red. The interpretation of the absolute value of the NDVI is highly informative, as it allows the immediate recognition of the areas of the farm or field that have problems. The average NDVI of a field varies according to the variety and phenological stage of the crop. Normalized Difference Water Index, NDWI, reflects moisture content in plants and soil. Vegetation cover on the Earth's surface undergoes severe stress during a drought. If affected areas are not identified in time, entire crops may be damaged. The early detection of water stress can prevent many of the negative impacts on crops. Remote sensing of land and the NDWI index can control irrigation in real time, significantly improving agriculture, especially in areas where meeting the need for water is difficult. The high NDWI values correspond to high plant water content and coating of high plant fraction. Low NDWI values correspond to low vegetation content and cover with low vegetation. During periods of water stress, the NDWI rate will decrease. The NDWI index for assessing risk of fire is used to determine the presence of moisture in vegetation cover. Higher NDWI values indicate sufficient moisture, while a low value indicates water stress. Normalized Difference Red Edge, NDRE, is an index which is sensitive to chlorophyll content in leaves, variability in leaf area, and soil background effects. Chlorophyll content helps us in determining how green a leaf appears. High values of NDRE represent higher levels of leaf chlorophyll content than lower values. Soil typically has the lowest values, unhealthy plants have intermediate values, and healthy plants have the highest values. NDRE is a better indicator of vegetation health than NDVI for mid to late season crops that have accumulated high levels of chlorophyll in their leaves. Now you know about NDVI, NDRE, NWI. Let's do a small assessment. What are the different numbers on the next slide?